Hi everyone! Last time we talked about linear systems in the xy plane. Today let's talk about linear systems in the space. So in the space we're going to have three variables x, y, and z. So let's talk about systems of three linear equations. So three linear equations corresponds to three planes in a space. So we also have three possibilities. One solution, no solution, and infinitely many solution. So what is the picture for one solution? So we can have three planes intersect together to get a unique solution. So let me try to draw the picture. So we have one plane, and then we have another plane, and then we have the third plane. Okay, and you can see the intersects right here. So this middle point, you can see those three planes intersect together and we get a unique solution. So this is the picture of it. Okay, how about no solution? Well, no solution, one picture could be we can have two of the planes, they are parallel, and then the third plane intersect them. So in this case, we don't have a solution for all the three planes intersect, right? So even though these two planes intersect at this line, these two planes intersect at this line, but also these two lines are parallel, so they don't have intersection. Okay, we can also have a picture look like let me try to draw it. We can have one plane look like this, and then we can have one plane look like this, and the other plane we can have it look like this. Can you imagine? So we have those three planes. They don't have common intersections, so there is no solution for the systems. How about infinite many solution? Well, we can have the three planes intersect at a line like this, or in this guy. Okay, can you imagine we have the three planes that intersects at a line? So then we get a one parameter family. So we have infinite solutions, and this is a one parameter family. You can see the intersection is just like a line, so a line is one dimensional. And then the next picture, we can actually have all the three planes, they're the same plane. So all the three planes, they coincide to be the same plane. Then the intersection is this plane, right? So that's why this is a two parameter family. Two parameter family because this is two dimensional. Okay, so one parameter family is like you're gonna have a parametric equations for x, y, z. They are a function of one parameter t. Two parameter family means like you have x, y, z. They are functions of s and t. So we have two parameter s and t. Okay. So this is the picture. There could be more picture than this. I just want to give you an example. Okay. Alright, so let's see how to solve the following examples. Example 5, solve the systems. So I will recommend you to use the elimination method. Okay, so let's compare the coefficient of x, y, and z. Looks like the coefficient of x is easier to work with. So let's use elimination method. The first step, because the coefficient of x are easier to work with, so let's eliminate x. Okay, so how do we do that? Well, what is the least common multiple? least common multiple of 1, 3, and 2 is 6, right? So equation 1, 2, 3. Okay, please write down the operations in all your steps because there are many different ways to solve a linear system. So I want you to write down the steps so that I can follow your method. I know what you're doing in each step. Okay, so how do we get the LCM? Alright, so the first equation we can multiply by 6, right? So first equation we can multiply by 6, and then we get 6x plus 12y plus 6z equals 6 times 4 is 24. Okay, and this is equation 4. Second equation we multiply by 2. 2 times 3 is 6x. 2 times 8 is 16y. 2 times 7, 14z. 2 times 20, 40. This is equation 5. In the third equation, we multiply by 3. 3 times 2 is 6. So 6x. 3 times 7, 21y. 3 times 9, 27z equals 3 times 2 is 6. 3 times 3, 9. Okay, 69. So this is equation 6. Okay, let's see. We pick 2 of them to get rid of x, and we pick 2 other of them to get rid of x. So let's see. Let's pick 4 and 5. Okay. So and let's use equation 5 minus equation 4. Why? Because you see the coefficient of y is bigger in the equation 5. Then if we use 5 minus 4, we can get a positive coefficient for y and z. If you use equation 4 minus equation 5, you will get negative coefficient of y and z. So we try to get positive coefficients. It's easier to work with. Okay. So equation 5 minus 4, 6x cancel. 16y minus 12y is 4y. 14z minus 6z is what? Is it 8z? 40 minus 24 is 16. Wow, can you see all the coefficients have factor 4? So we can both sides divided by 4 to simplify it. Then y plus 2z equals 4. Let's call this guy equation 7. Okay? So if at some points you can simplify it, please simplify it because you don't want to work with big coefficients, right? And then next we want to pick the 2 other equations to get rid of x. We can pick equation 4 and equation 6. We can pick equation 5 and equation 6. And I think maybe it's better to pick equation 5 and 6 because 21 and 16, they're closer together rather than 12 and 21. So we use equation 6 minus equation 5. 6x cancel. 21 minus 16 is 5. So 5y. 27 minus 14 is, let's see. 27 minus 14 is 13. Z equals 69 minus 40 is 29. So this is equation 8. So far so good, everyone? Okay, so let's see. Now we get the 2 equation with 2 unknowns. So which one we should eliminate? Well, it's better to eliminate the y, right? The coefficients of y are easier to work with. So we can put, next we want to eliminate the y, and the LCM is 5. So we just use the equation 7 times 5. We have 5y plus 5 times 2 is 10z. 4 times 5, 20. This is equation 9. And then we want to use equation 8 minus equation 9. Why? Because, you see, then we can get positive coefficients, right? So then we have 5y cancel. 13z minus 10z is 3z. 29 minus 20 is 9. Oh, nice. We can both sides divided by 3. 9 divided by 3 is 3. So we get z is 3. Alright, after we get z, we can use one of the equations 7 or 8 to solve for y. So equation 7 is easier. So then we can plug, let me put here. So plug in 7. We get y equals minus 2z plus 4. Z is 3, so minus 6 plus 4 is minus 2. And then we can plug in the one of the equation, 1, 2, 3. Which one is easier to work with? Equation 1, right? So we can plug in equation 1. We get x is negative 2y minus z plus 4. 2y, y is negative 2, so negative 2 times negative 2 is 4. Z is 3. Oh, so we get 1 plus 4 is 5. So we get x is 5. Y is negative 2. Z is 3. So we can express our answer in terms of points. So this is the points 5, negative 2, and 3. So we get a unique solution. So you can see this is a unique solution. That finished this problem. Okay. So don't forget that when you watch the lecture videos, you can control the speed, right? And before you play the video, please try to work on the problems first and then play the video to check your answers. Okay? So for math, it's very important to get enough exercise. Okay, so practice more. Alright, example 6. We want to solve the following linear systems. And let's compare the coefficients. Which one looks easier? It looks like x is easier to work with, right? So there are many ways to solve the systems. So I suggest you always compare which way is the easiest. Because if you pick a quicker way, maybe you just take 10 minutes to solve the problem. But if you pick a harder way, it could take you half an hour or an hour to solve the problem. So it's really quite different. So before you work on it, think about it. Which way is easier to work with? Okay. All right. So we choose to eliminate x, and the LCM is also 6, right? So let's see. First equation, we multiply by 2. 6x minus 2 times 8, 16y. 2 times 10, 20z. 2 times 22, 44. This is equation 4. Second equation, we multiply by 6. So 6x minus, 6 times 3, 18. 6 times 2, 12. 6 times 5, 30. The third equations, we multiply by 3. 3 times 2 is 6x. 3 times 9, 27. 3 times 8, 24z. 3 times that, negative 33. So this is equation 6. Okay, so let's see equation 4 and 5. Okay, shall we do equation 4 minus equation 5 or equation 5 minus equation 4? Which way will give us positive coefficients for y? So we should use equation 4 minus equation 5, right? Then the negative, so 6x cancel, negative 16y minus negative 18y become negative 16 plus 18, which is 2y. And then 20z minus 12 is 8, so 8z. 44 minus 30 is 14. Okay? Oh, can you see all the coefficients have factor 2? So we can divide it both sides by 2. Then we have y plus 4z equals to 7. This is equation 7, right? And then we want to pick 2 other equations to get rid of x. Let's see, which one? Maybe we should use 5 and 6. Okay, so we use equation 5 minus equation 6. 6 cancel. Minus 18 plus 27 is 9y. And then the 12 minus negative 24 becomes 12 plus 24, which is 36. 30 minus negative 33 is 30 plus 33 is 63. Well, can you see all the coefficients have factor 9? So let's divide it both sides by 9. We get y plus 4z equals 7. Oh, what happened? Do you see we get the same line? So when we when we subtract them, we just get 0 equal to 0. When you see 0 equal to 0, we know there are infinitely many solutions. And actually, because of the same line, we know there is a one parameter family. So how do we express this? Well, look at this line. Maybe it's easier to solve for y in terms of z, right? So we get y is minus 4z plus 7. Okay, so then we let z be t, then y is minus 4t plus 7. And how about x? How do we get x? Well, look at those 3 equations. Which one is easier to solve for x? The second one, right? Second one. So from equation 2, we get x equals, well, we move the 3y to the other side, it becomes positive. We move the 2z to the other side, it becomes negative. And we still have the 5. So 3y, y is negative 4t plus 7. Z is t. Okay, so let's simplify it. 3 times 4, negative 12t. 3 times 7, 21. Minus 2t plus 5. Okay, how many t do we get? Minus 14t. And what is the constant? 21 plus 5 is 26. So this is the x. Now can you see we have x, y, z. They are functions of t. Now we are done. Because we can use the point notation. X is minus 14t plus 26. Y is minus 4t plus 7. And z is t. And then t is any real numbers. Okay, so you can use this notation, r is real numbers. Oh, this notation means it belongs to, it is in. So t is the element of the set of real numbers. So this means in. So you can also say t is in minus infinity to infinity. Then they mean the same things. Okay? So we get one parameter family. So what happened when we have 2 parameter family? Okay, so let's see. Let me write down here. Okay, when do we have 2 parameter family? Okay, so if all of the 3 planes are actually the same plane, okay, So you might get, for example, okay, so x minus 3y plus 2z. Okay, I can multiply by 2, so 2x minus 6y plus 4z equals 10. I can multiply by 3, x minus 9y plus 6z equals 15. Okay, so how do I get the second equation? I just multiply by the first equation by 2, and then how do I get the third equation? I just multiply the first equation by 3, so that actually they're the same plane. Okay, so all three of them are the same plane. So that's why a plane is two-dimensional space. So it's we have two parameter family. So we can let y be s, let z be t, and then x is 3y minus 2z plus 5, while 3y, y is s, z is t. Now we get x is 3s minus 2t plus 5, y is s, z is t. So this is a two-parameter family. So s and t, they are real numbers. Okay? All right. So this is session 3.1. So if you have any questions, feel free to print screen and then ask me. Have a nice day. Bye.